Hello dear friends, myself Nitin, and today we will be studying about tropical cyclones. Tropical cyclones. So as we used to do it, we will study this topic also in a very structured manner. So I would request you to have a copy and pen with you, and you can note down the important keywords and important points from this lecture for the examination purpose. Okay, so first we will note down that what all things we are going to cover in this video. First is what is tropical cyclone, means the definition of tropical cyclone. Next is the structure of tropical cyclone and stages of tropical cyclone. Our third point is classification of tropical cyclones. Our fourth heading is origin or conditions required for tropical cyclones. Fifth point is characteristics of tropical cyclones. Our sixth point is their distribution, means the areas in which these are formed. Distribution or areas for tropical cyclone. Seventh one is naming. How we will see that how these tropical cyclones are named. Naming of tropical cyclones. Eighth point is hazards or impact of tropical cyclone. And the ninth and the last point is mitigation techniques. Mitigation techniques here means how these cyclones or the hazards caused by these cyclones can be minimized or stopped. So we will try to cover all these 9 topics one by one under this main heading, tropical cyclones. I hope you people will be noting it down. So before we start with the definition, our first heading, definition of tropical cyclone, we would like to cover few small topics so that it will help you to understand this topic. First one is the pressure gradient and movement of winds. Now listen carefully about these few topics so that this will help you to understand the main topic, tropical cyclone. Now what is pressure gradient? Pressure gradient means difference in the air pressure between 2 points. For example, this is a place and this is second place. I consider this as high pressure area and this place as low pressure area, then it is fixed that the movement of wind will always be from high pressure area to low pressure area. Means if there is a difference between the pressure of 2 points, this and this, then there will be a pressure gradient, PG, pressure gradient between these 2 points, and the movement of wind will always be from high pressure to low pressure. Remember this first point, means pressure gradient and movement of the wind from high pressure to low pressure. Our second point is Coriolis effect. Now what is this Coriolis effect? Now what happened that this effect is mainly due to the rotation of the earth. What happened that due to rotation of the earth, means when earth is rotating like this, due to rotation of the earth, it used to make the winds or the objects, means moving over the surface of the earth, to rotate in the northern hemisphere, means from 0 degree to 90 degree north. This Coriolis effect, means due to movement of the earth, it used to make the object shift towards right or move the objects to move towards the right. And what happens in 0 to 90 degrees south latitudes, this Coriolis effect, it used to make the objects move towards left, or it used to create a force, means this Coriolis force actually used to means impact the moving object. For example, this is a moving object, then under the Coriolis force or Coriolis effect in the northern hemisphere, this will turn rightwards. And for example, if this is a moving object, then the Coriolis force in the southern hemisphere will make this object to turn leftwards. So this is the second means a small topic, Coriolis effect. Do remember that this Coriolis effect is not present here at 0 degree equator. Okay, means for this Coriolis effect, it used to increase from equator towards poles, means from 0 degree equator towards 90 degree north and 90 degree south, but at 0 degree equator this Coriolis force used to remain 0. So this is the second topic. Third one is trade winds. Now what are these trade winds? Now these trade winds are planetary winds, means which used to blow from subtropical high pressure regions towards equatorial low pressure regions, means from the northern hemisphere also, from the southern hemisphere also, these winds used to move towards the equatorial low pressure areas and used to converge here at equator. Now if I draw these three lines, now this will be say 30 degree north, 30 degree south and 0 degree, this 0 degree equator. Now these trade winds are moving from this region, means this region is a high pressure region, this region is also a high pressure region, this region is a low pressure region, high pressure, low pressure. Now these trade winds, they move due to rotation of the earth, means these are also known as planetary winds, means due to rotation of the earth, these winds used to move opposite to the rotation of the earth, means earth used to rotate from west to east and they used to move from east to west. So, and also from wind, we know that wind always move from high pressure to low pressure. Since this area is high pressure one and this one is low pressure one, these winds used to move in this region and try to converge here at equator. So this is the third one. And the fourth point is ITCZ. Now ITCZ here means intertropical convergence zone. Now what is this? ITCZ is a high temperature and low pressure area. Means here means this is a high temperature and low pressure area where winds used to converge. So remember that this is not a particular line, it is actually a belt, means this used to cover a particular region. For example, here this portion will be a ITCZ area from 0 to say 5 degree or 10 degree north and 10 degree south. This region will be ITCZ. Generally this ITCZ is near equator, but this is not at fixed place, means this used to move, it used to shift northward till Tropic of Cancer and southward till Tropic of Capricorn. Why it used to shift? It used to shift because of apparent movement of the sun. Means during the month of June, when sun is directly overhead Tropic of Cancer, then the this ITCZ area lies over Tropic of Cancer. And during the month of December, when sun is directly overhead Tropic of Capricorn, then this ITCZ zone lies over the Tropic of Capricorn or near the 23 degree to 30 degree north and south latitudes. Okay, so I think if you are clear with these four topics, means pressure gradient, means movement of wind from high pressure area to low pressure area, coriolis effect, means the rotation of the wind or the moving object over the surface of the earth due to rotation of the earth. Third is trade winds, means movement of wind from eastern to east direction to west direction and towards from subtropical high pressure belt towards equatorial low pressure belt. And ITCZ means a region of high temperature and low pressure where winds used to converge. Okay, remember that this ITCZ used to shift its position with the apparent movement of the sun from 0 degree to means 25 degree or 30 degree north and from 0 degree to 25 degree or 30 degree south. Now if you are clear with these 4 points, we will come to our first topic, that is what is tropical cyclone. So now we will come to our first topic, that is definition for tropical cyclone. So how we define tropical cyclones? Tropical, you can note it down, tropical cyclones are intense rotating column of air mass or clouds formed over warm tropical waters in a manner such that the rotating column has a low pressure center and closed isobars. So this is the definition for tropical cyclone. Tropical cyclones are intense rotating column of air mass or clouds formed over the warm tropical waters in a manner such that the rotating column has a low pressure center and closed isobars. Now we will study that means what this actually means. See what happens, that now consider this as a sea surface area. Now we have already discussed that air moves from high pressure towards low pressure. Now consider that this portion or this region is a low pressure region. Then what will happen, that air from all this other portion means high pressure region high pressure region near to this low pressure region. Now air from all these sides will try to move towards this low pressure region. Now we know that under the impact of coriolis force, we have studied that what will happen, the coriolis force will act perpendicular to the movement of this air, okay, and it will try to put this into a rotating motion or rotating column, something like this. Now when this air means all this air trying to move toward this low pressure region, when they convert into a rotating column of air, then this lead to conversion into tropical cyclone. Now actually what happens when when this air starts converting into rotating column, then it will try to move upwards. We know that why it we know that warm air used to move upwards, means it get heated and it used to move upwards. When this air will move upward, then of course the air lying in the nearby region, this will, all this air will try to occupy this space. Then what will happen in this case? More air will run into the center and more spiral, means spiraling of the air will take place, and this will convert into a fast moving storm that is known as cyclones. Now so remember this, how means this the moving air used to convert into cyclones. It is in this manner. Okay, now few things which we used to remember here are intense rotating column. Intense rotating column, here it means that the speed of the wind, means the wind speed, it must be greater than 118 km per hour for the means disturbance to be called a cyclone. Intense rotating column means the wind speed or the rotation or the rotating wind speed must be greater than 118 km per hour. Next is warm tropical waters. Warm tropical waters here means that the sea surface temperature, it must be greater than 27 degrees centigrade. Sea surface temperature means the temperature of the surface of the ocean where the tropical cyclone is formed. So that sea surface temperature, warm tropical waters means sea surface temperature must be greater than 27 degrees centigrade. And next is low pressure center. Low pressure center means this, means there should be a low pressure center, and near to these low pressure center there should be high pressure centers from where the winds used to convert or move toward this low pressure center, where these winds used to get convert into the rotating column of the air or swirling column of the air under the impact of coriolis force. Okay, and closed isobar here means, isobar means regions with similar kind of air pressure or similar air pressure. Closed isobar here means, for example, if this is one place with say air pressure of 950 millibar, then this will have completely, means all the points will have an air pressure of 950 millibars, and very next to it will be 951 millibar. Then very next to it will be having 952 millibar. So we see that the center will have the lowest air pressure, and as we move outside the air pressure is going to increase 950 millibar and so on. Okay, so remember these the definition of tropical cyclones and the meaning of the important keywords present in this definition. Okay, if you are clear with this definition, we will come to our next heading under this tropical cyclone, that is the stages of tropical cyclone and structure of tropical cyclone. Now we will come to structure of tropical cyclones. I have made a diagram here for you. Now see what happens, means this is a low pressure region. Now air from all the sides, means nearby high pressure region, this air used to move toward this low pressure region, and then this air used to get converted. We have already studied that under the impact of Coriolis force, it used to get converted into swirling column of air, and then it tries to, this means this warm air tries to move upward, and when this reaches to a tropopause, means certain height level, then this air used to move outward from here and from this region. So what happens that the center region, means this low pressure region, okay, from where the air moves upward, this region is known as eye of the tropical cyclone. Okay, now this eye, what is the characteristic of this eye? Now this eye region is a cloudless region, means this eye region is cloudless, means no clouds are present. Rainless, means no rain used to occur in this region. Very calm and clear skies. So remember, these are the characteristics or features of eye portion of the tropical cyclones. Okay, eye is the center portion or the center low pressure region of the tropical cyclone, and it is characterized by cloudless, rainless, calm and clear skies region, and sinking air, means this region is characterized by sinking air, means the air used to sink here, and we know that rainfall is always caused by the rising air, rising warm air, okay, not by the sinking air. So this region used to remain rainless. Now on the verge of this eye, here remains this region which is known as eye wall. Now what is the characteristic of eye wall? Eye wall is the most destructive part of the tropical cyclone, means direct objective questions are asked based on this, that which portion of the tropical cyclone is the most destructive one, then that is not the eye but the eye wall. Why eye wall? Because the means wind speed is very high here in the eye wall region, okay, and also this is characterized by cumulonimbus clouds and heavy rainfall. So remember this two characteristics of the eye wall region: wind speed very high, characterized with very high rainfall through cumulonimbus clouds. So on the verge of eye is the eye wall region. Okay, next is this portion which is also known as rain bands. Rain bands. Now what are these rain bands? Now these rain bands are on the verge of eye wall or the areas, means lying close to eye wall, next to eye wall, means in a swirling manner, and these are characterized by heavy thunderstorms and clouds, means cumulonimbus clouds can be seen here also in this rain band region, along with means heavy thunderstorms in this rain band region. Now what happens that we know that this means the rising column of the air, it can reach to maximum of 13 kilometer of height, means on average say 13 to 14 of 12 kilometers of height. So this is also one of the means portion of this structure, means maximum height to which this reaches, means this swirling column reaches, that is 13 kilometer. Okay, and what can be the width of this cyclone? Means this total means from eye to eye wall and rain band region, that can be 300 to 500 kilometers of width. And what will be the width of this eye region? This generally lies between 30 to 50 kilometers width. Now also remember that this tropical cyclone used to move from east to west, and generally the speed is 20 to 30 kilometers per hour. This is an average speed. Okay, this can be more than that and even less than that. Now next is that where are these tropical cyclones formed? These are formed in the region where the sea surface temperature is greater than 27 degrees centigrade. Now why it should be greater than 27 degrees centigrade? Because these tropical cyclones are thermally induced, means the source of their energy is the sea surface temperature, means this warm surface, warm ocean surface, it used to ensure that this means adequate amount of moisture is present in the air, and due to that adequate amount of moisture or the warm air, it used to cause the upliftment of the air. Now when the air gets uplifted, it releases latent heat of condensation. Now means when this warm air it rises, it starts cooling down. Okay, when it starts cooling down, it releases latent heat of condensation, and that latent heat of condensation is another source for means energy to tropical cyclones. Means the greater the amount of latent heat of condensation, the greater is the amount of energy in the cyclones. So I hope you remember all these points. You might have noted it down. The structure and the important features of eye wall, rain bands. Okay, the height of the rising of the air column. Okay, the width of the cyclones, the width of the eye portion, the sea surface temperature, moving speed, and latent heat of condensation. Okay, if you have noted it down this, then our next topic under the structure as well as it was stages. Now cyclone has 4 stages. First one was its formation. Second was intensification. Third one is maturity. And remember the fourth one is decay of the tropical cyclone. These are the 4 stages of tropical cyclone. Means initially the tropical cyclone is formed. This is how we have seen that how it is formed. And then next one is intensification. How this tropical cyclone get intensified? Means with the release of latent heat of condensation and more air, means moving into this low pressure center, and more swirling or movement or rotation of the air. When the means wind speed when the speed start increasing, then that is known as intensification. Maturity means when the cyclone has reached to its maximum speed and maximum movement. Okay, then that is known as maturity stage. And decay, we know that the source of energy for these cyclones are the sea surface temperature or the warm ocean surface temperature, which is 27 degrees centigrade. So by the time these cyclones remain over the ocean, they have energy. But as these cyclones are moving from east to west, a time will come when these cyclones will strike the land surface, okay, or the continents. As soon as they strike the continents, they will not have the means their source of energy, that is warm ocean surface, and so they will start decaying or losing their energy. And that is why when tropical cyclones strike the means continental portion or land portion, they used to release their all energy there, causing destruction there, and in that way they used to get decay or end. Okay, so I hope you people have noted it down, and you might have also understood the meaning of these 4 terms: formation, intensification, maturity, and decay of tropical cyclones. Our next heading will be classification of tropical cyclones. So we will come to our next topic or next heading under this tropical cyclones, that is classification of tropical cyclones. Now generally these tropical cyclones, are characterized means classified based on 2 things mainly. First one is wind speed or speed of rotating column. To remember this, that these tropical cyclones are mainly classified based on 2 things. First one is speed of rotating column, first one, and second thing is the region where they are formed, or the region or the place where they are formed. So these are the two ways or two things based on which tropical cyclones are classified. We will see one by one. See, based on wind speed, these are classified as, first one is tropical disturbance. Now, when it is tropical disturbance, when the rotating wind speed is less than 40 km per hour. Remember this, it is known as tropical disturbance when wind speed is less than 40 km per hour. Second, it is known as tropical depression. When it is known as tropical depressions, when the wind speed is between 40 to 60 km per hour. Okay, it is known as tropical depression when wind speed is 40 to 60 km per hour. Third one is tropical storm. When it is called tropical storm, when the wind speed is between 60 to 118 km per hour. And fourth one is cyclone. When it is called cyclone, when wind speed is greater than 120 or 118 km per hour. So remember this, based on wind speed, it is classified in terms of tropical disturbance, tropical depression, tropical storms and cyclones. Now what happens based on this regions where they are formed, this cyclone is classified as hurricane, okay, typhoons, Willy Willy, typhoon, Bagu. These are different names for the same, also of course cyclones. These are all names for the same thing but in different regions, means based on regions these are classified like this. Now it is known as cyclones means cyclones, where we call it cyclones only when the the disturbance is in Indian Ocean. In Indian Oceans when such means great these tropical storms or this disturbance or depression, when these used to come in the Indian Oceans, we used to name it as cyclones. When the same used to come in the in the hurricanes, hurricanes are when they are formed in the Gulf of Mexico and Caribbean Sea region. So when we call it hurricane, when the same cyclones are formed in the Gulf of Mexico or the Caribbean region, then we are called it as hurricane. When they are formed in the Indian Ocean, we name as cyclones. And when the same, we call it as typhoons when they are formed in the North West Pacific region. In the Northwest Pacific region, the same things are called typhoons. In the Australia, these are known Australia and New Zealand region. Australia and New Zealand region, these are known as Willy Willy. In Japan region, they are known as Typhoon. While in the Philippines, these are known as Bagu. So I hope you are clear with the classification of tropical cyclones based on wind speed, tropical disturbance, tropical depression, tropical storms and cyclones, and based on the regions where they are formed into cyclones in the Indian Ocean, hurricanes in the Gulf of Mexico and Caribbean Sea, typhoons in the Northwest Pacific, Willy Willy in the Australia and New Zealand region, typhoon in the Japan, and Baguio in the Philippines region. So if we are clear with this classification of tropical cyclones, we will move to our next heading under this, that is origin or the conditions needed for a tropical cyclone to be formed. Now we will come to our next heading, that is origin or conditions required for tropical cyclones. So you can note it down. What are the conditions or what is the reason for the origin of these tropical cyclones? First one is continuous supply of warm and moist air. Now, how will be this continuous supply of warm and moist air? Of course, due to sea surface temperature greater than 27 degree centigrade. Continuous supply of warm and moist air due to sea surface temperature greater than 27 degree centigrade. So this is the first reason for, or the first condition for the tropical cyclones to be formed, that the region over which tropical cyclones are to be developed, the sea surface temperature must be greater than 27 degrees centigrade, because these sea surface temperature or the warm oceans are the main region or the source for energy to tropical cyclones. How? We know that means the warm air or the warm or moist air, due to this warm ocean surface, it used to uplift, and while uplifting it releases latent heat of condensation, which provides energy to rotating air column or rotating wind to form cyclones. So this is the first condition. Second is presence of Coriolis force. Now we know that Coriolis force is required in order to provide a rotating column to a straight moving wind. Means, so we know that cyclones are what? Cyclones are rotating column of air. So Coriolis force is the second main requirement for tropical cyclones. Now we know that this Coriolis force is not present, it is zero at the equator. At equator, Coriolis force is 0. So where are these cyclones mainly formed? These are mainly formed above 5 degree north and above 5 degree or below 5 degree south latitudes, and mainly these are formed in the 20 degree north to 30 degree north latitudes, or 20 degree south to 30 degree south latitude. This is the region where maximum tropical cyclones are formed. Generally these cyclones are formed above 5 degree north latitude or below 5 degree south latitude. Why? Because the Coriolis force is 0 near the equator. So, and we know that Coriolis force is must for tropical cyclones because it provides rotation or rotating column of winds, or it makes the straight moving wind to rotate. So this is the second condition, Coriolis force. What is the third one? Third one is upper air divergence. Now what is this upper air divergence? We know that what happens, that the warm and moist wind which used to converge at a low pressure center here, these used to uplift. These air used to uplift in a rotating column or a rotating manner. When these means this reaches to tropopause, this must upper air divergence must, this air must diverge. Okay, when this air gets cool, it must diverge to the other part, so that it ensures that the means air current from below, they are continuous. Means if this air will not diverge properly, then the current supply from below or the energy supply from below will reduce, and that will then reduce the intensity of cyclones. So in order to ensure that the cyclone forms are of good intensity or the without any breakage, this air must diverge, and it ensures the air current supply from below. Air divergence. Now this is air divergence, and this ensures the air current supply from below. So this is the third point, upper air divergence. Now fourth one is low vertical wind shear. What is this low vertical wind shear? Wind shear means the change in the speed of wind with change in altitude or with increasing altitude. So here it refers to low vertical wind shear. It means that the wind speed should not change much, means in the lower troposphere and in the upper troposphere. For example, if the wind speed here is 60 km per hour, it should remain near about 60 or 61 here also in the upper troposphere. Okay, 60 or 61 in the upper troposphere means this wind speed in the lower troposphere, in the upper troposphere must not change or okay. So this is low vertical wind shear, or the wind speed means responsible for tropical cyclones to be formed. Fifth one is presence of disturbance or ITCZ region. Now presence of disturbance means, or ITCZ region means, generally most of the cyclones are formed in this region, ITCZ regions. Why? Because disturbance is already present there. Means we know that ITCZ region, this is the ITCZ region, and this is characterized by converging air masses, means low pressure area and wind from high pressure area used to converge here. So this ITCZ regions, we have already studied this ITCZ region used to shift due to apparent movement of the sun. It used to shift northward also, southwards also with the apparent movement of the sun. So in this ITCZ region, wherever this will be located at a particular time, this region sees the formation of maximum cyclones because of presence of disturbance, means convergence of air mass into the low pressure region. So this is the fifth one. And the sixth one is presence of high humidity. High humidity or the high humidity here means greater amount of moisture should be present in air. Greater amount of moisture present in air. The greater the amount of moisture that will be present in air, the greater will be the amount of latent heat of condensation which will be released on the warm air rising up, and the greater the amount of latent heat of condensation released, the greater will be the intensity of the formation of tropical cyclones. So these are the 6 points which are conditions required for tropical cyclones to be formed. I hope you people have noted it down. If you have noted it down, we will move to our next heading, that is characteristics of tropical cyclones, means what are the things which we should remember about tropical cyclones. So now we will come to characteristics of tropical cyclones. What are the characteristics of these tropical cyclones? First one is, these are formed over warm tropical waters between 5 degree to 30 degree latitudes, means north and south, where SST T, sea surface temperature is greater than 27 degree centigrade. So this is the first characteristic, that these tropical cyclones are formed over warm tropical waters between 5 to 30 degree latitudes north and south, and where sea surface temperature is greater than 27 degree centigrade. Now we know the reasons why sea surface temperature greater than 27 degree is required and why 5 degree to 30 degree latitudes, because from 0 to 5 coriolis force is 0, and above 30 degree latitude why these cyclones are not formed, because the sea surface temperature it decreases above 30 degree latitudes, means the temperature of the ocean surface water it becomes very low, means cold water is present above 30 degree north latitude and below 30 degree south latitudes. Okay, so this is the first condition or the first characteristic of tropical cyclone. Second is they move from east to west. We know that these are formed in the tropical regions, and means due trade winds move from east to west. Okay, so under the influence of trade winds they move from east to west, or just opposite of the rotation of the earth. Earth rotates from west to east, so these tropical cyclones move from east to west in the tropical region. So this is the second characteristic. Third characteristic is wind speed generally lies between 60 to 200 km per hour in cyclones. Means the wind speed or the rotating wind speed generally lies between 60 to 200 kilometers in cyclones. Okay, so this is the third characteristic. What is the fourth one? Fourth one is tropical cyclones strike eastern part of the continents or countries. Now we know that they move from east to west. For example, this is India southern portion, peninsula plateau. We know that tropical cyclones move from east to west, means they will be moving from here to this east to west direction. Then of course they will strike, means in most of the cases they will strike here on eastern part of the country or the eastern part of the continent. Means these tropical cyclones can strike here in India as well as here in Bangladesh, here in Myanmar, but they will strike their eastern part. So do remember that these tropical cyclones generally strike the eastern part of the continents or country. You can write here generally, because sometimes they even strike the western part, because those tropical cyclones which are generated in the Arabian Sea region, we know that sometimes they used to strike the Maharashtra or the Gujarat region. Okay, generally most of the tropical cyclones are seen to be formed in the Bay of Bengal region, and they used to strike the means eastern part of the India or eastern part of the continent. So this is the fourth characteristic of tropical cyclone. Now what is the fifth characteristic? What is the fifth characteristic? Fifth characteristic is that these are strong over oceans and weak over land. Now we know that the main source of energy for tropical cyclones is the sea surface temperature or the warm ocean surface, which is 27 degrees centigrade or higher than that. So when these tropical cyclones remain over the ocean, they used to ensure that there is continuous supply of energy to them, and then they are strong there. When these tropical cyclones strike the land portion, they lose all their energy there, and due to unavailability of the energy, means due to unavailability of the warm ocean surface, they become weak and get then they used to end there on land. So this is the fifth characteristic. Now sixth one is Now these tropical cyclones, they used to rotate anti-clockwise in northern hemisphere and clockwise in southern hemisphere. So do remember this, tropical cyclones rotate anti-clockwise in the northern hemisphere. Northern hemisphere means 0 to 90 degree north latitude, and they used to rotate clockwise in the southern hemisphere. This is the sixth characteristic. And the seventh and the last one is, these have closed isobars. Okay, now closed isobars, and what does it mean here? Means these closed surface means, if this I have already explained this to you, means closed isobars means these tropical cyclones are characterized by closed isobar. It means if the means the pressure here in the center is 995, means this will be again a closed region, and the temperature means pressure here will be 996, 997, means very near about, means the lowest one in the center and the highest one outside. Okay, so this is the seventh and the last characteristic of this tropical cyclone. So I hope you people have noted it down, all the seven. The direct questions means whatever topics I have covered under this main heading tropical cyclones, these are means directly asked in 10 marks question or 15 marks question in the mains examination, okay, or in any of the subjective examination. So if you have noted it down properly, you can use this notes to directly write it down there in the examination. So I hope you people have done with these characteristics of tropical cyclones. If we have completed, then our next topic will be the regions or the distribution of tropical cyclones, means the regions where these tropical cyclones are formed. Now we will come to distribution or regions of tropical cyclones. Now we know that these are formed in the tropical region. These tropical cyclones are formed in the tropical regions, which is generally from 30 degree north to 30 degree south latitudes. Now different regions where they are formed. First one is North Atlantic, second one is North Pacific, third one is North Indian Ocean, fourth one will be South Atlantic, fifth one will be South Pacific, and sixth one will be South Atlantic. Now these are the six regions. Now I am not mentioning Arctic and Antarctic. You might be understanding that why I am not mentioning Arctic and Antarctic, because those regions are very cold regions. I mean the sea surface temperature is very cold, and we know that we require minimum of 27 degrees centigrade of ocean water sea surface temperature for cyclones to be formed. Okay, now you need to remember that in North Atlantic, when we can observe, in which months we can observe these cyclones. So you remember that in north what happens, that the sun used to shine directly over Tropic of Cancer or in the northern hemisphere in the month of June. Means in the month of June, that portion means either the ocean portion or the land portion, those used to fall near the Tropic of Cancer or in the northern hemisphere, that would be much warmer than, means it would be much warmer, especially that is required for the tropical cyclones to be formed, that is 27 degrees centigrade temperature. So in the North Atlantic, we see that most of the cyclones are formed in the month of August to October, because after since the sun used to remain over in the month of June and July near the Tropic of Cancer, so during those months the sea surface gets warmed much above 27 degrees centigrade, and it makes it ensures that the first condition for tropical cyclones to be formed is met. So in the North Pacific Ocean, August to October. Similarly in the North Pacific Ocean, because this North Pacific portion of the North Pacific region which lies in the tropics, we will see that in between August to October maximum cyclones are formed. In the North Indian Ocean, we will have two major periods where cyclones are formed. In the month of May to June, you might be understanding due to the sun's position, okay, over the Tropic of Cancer or in the northern hemisphere in the month of June. And second is in the month of October, November. Now, this is mainly due to warm ocean current present in the northern Indian Ocean, okay, or the movement of the warm ocean currents in the northern Indian Ocean. So remember these three things: for North Atlantic, August to October for North Pacific, and for North Indian, May to June and October to November. These are the months or the periods we can find the tropical cyclones in this region. Now we will come to South Atlantic. Now see, South Atlantic portion, generally we don't find any cyclone. So do remember that direct objective questions are asked that in which of the following oceans we generally or hardly find any cyclones, then that is South Atlantic. Why we don't find any cyclones here in South Atlantic? Due to presence of cold water current, cold ocean current, that is known as Bengola. Now in the South Atlantic Ocean, we have a cold ocean current, that is Bengola current, and we know that for cyclones to be formed, the sea surface, the ocean surface temperature should be 27 degrees centigrade or above that. But this cold ocean current used to reduce the ocean surface temperature much below 27 degrees centigrade, and so means cyclones are not formed in the South Atlantic Ocean. Then in the South Pacific Ocean and South Indian Ocean. In the South Pacific Ocean, of course, we will find the cyclones from the month of January to March, and in the South Indian again January to March. Now we know that why we find maximum cyclones from January to March in the southern hemisphere or in the South Pacific or South Indian Ocean, because we know that Tropic of Capricorn, means sun used to be directly overhead at Tropic of Capricorn. Sun used to be directly overhead Tropic of Capricorn in the month of December. So those portion, means all those portion near to Tropic of Capricorn, either sea or land surface, that used to get heated much above 27 degrees centigrade for cyclones to be formed. So maximum cyclones we used to observe in the month of January to March in the South Pacific and South Indian Ocean. So this was about distribution. Next is naming of tropical cyclones. Now how these tropical cyclones are named? No, actually we have 6 regional specialized meteorological centers in the world, RSMCs, and 5 regional tropical cyclone warning centers which used to issue names for tropical cyclones. And Indian Meteorological Department, IMD, is also one of these 6 regional specialized meteorological centers which used to issue the names for the cyclones. Now this actually IMD used to also provide advisory to 13 countries in the Indian Ocean region. Those 13 countries, India, Pakistan, Bangladesh, Myanmar, okay, then Oman, Yemen, Saudi Arab, and all these countries, Iran, all these countries are a group of 13 countries, means Indian Meteorological Department used to issue the advisories for these 13 countries regarding tropical cyclones. Now what happens regarding naming for each of these oceans, for example for North Indian, North Pacific, North Atlantic, for each of these oceans where, or each of these regions where cyclones are formed, means there are group of countries, means for example in the North Indian Ocean, this group of 13 countries, means each country have already means given a name for a cyclone. Okay, the list is already prepared. These countries have given name, for example in 2020 each country have suggested, say for example 12 to 13 names. Each of these countries, means totally we might be having near about say 100 names. Okay, so what happens every time a cyclone occurs in the North Indian Ocean, means in systematic order a name will be taken and given to that particular cyclone. For example, the recent cyclone in the North Indian Ocean has been named as Mandos, and this name was suggested by UAE. Okay, and the next cyclone which will be occurring in the North Indian Ocean will be named Mocha, means this has already been decided because it has been taken from the list which has already been prepared, and this Mocha name has given by Yemen. Similarly, India has also suggested several names. Okay, similarly Pakistan has suggested, Bangladesh has suggested, means every time a cyclone occurs in the North Indian Ocean, a name will be taken from the list in systematic order and it will be given to means that cyclone. Similarly for North Atlantic Ocean, or for example in North Pacific Ocean, countries like Canada, okay, USA, Mexico, these countries may have formed a list, okay, of cyclones, means they have named, and every time a hurricane or tropical cyclone used to occur in those regions, then those are named according to the list prepared by these countries. Okay, so this is how, means tropical cyclones are named. Now when we are done with the distribution of tropical cyclones and naming of these tropical cyclones, if we are done with these two topics, now we will come to, means other two topics which are, means destruction or hazards caused by the tropical cyclones and ways to mitigate the same. Our last two topics are destruction or hazards caused by tropical cyclones. Now what happens is these tropical cyclones have too much energy and in them. So when these tropical cyclones, they strike the coastal areas, they release energy there, thereby causing floods. Means these tropical cyclones used to cause floods in the coastal areas. Then they used to damage buildings, okay, ports, ships, roadways, okay, poles. Then they used to cause damage to animals and plants in the coastal areas. So this is the destruction caused by the tropical cyclones mainly in the coastal areas. Along with this tropical cyclone, ignore that these tropical cyclones only cause the destruction. Okay, these tropical cyclones are also, means helpful, as they used to cause rainfall, say 200 to 500 kilometers away from the coast. Now we see that means coast rainfall in the months of for example August or October or especially in the parts of Odisha, Chhattisgarh, Andhra Pradesh, Telangana, all those rainfall are caused by the cyclonic, means they are known as cyclonic rainfall, which are caused by the cyclones, and those rainfall are very good for agriculture purpose. Now if you come now we have done with this destruction and hazard caused by the tropical cyclones, and also means usefulness of this tropical cyclone. We will come to ways to mitigate the hazards. Ways to mitigate or minimize impact of tropical cyclones. Now what are two ways? There are actually two ways: structural and non-structural. So if you are asked in the examination, you can also divide it into two parts: structural and non-structural. Structural means what? Means we used to make our buildings, cyclone resistant buildings in coastal areas should be cyclone resistant. Okay, then we have to make cyclone centers, means this is another structural way. And similarly, two three things more you can write in structural under structural, that means how to mitigate this tropical cyclone. Similarly, in non-structural, what we can write is that cyclone warning system, or say Doppler weather radar. Use of cyclone warning system or Doppler weather radar to get prior information about cyclones, so that we can accordingly evacuate the coastal regions. Next would be means making of embankments in the coastal regions. Okay, embankments will help to reduce the impact of cyclones in the coastal regions. Third is the use of mangrove cultivation. Cultivation in the coastal area, especially in the Sundarban regions or in the Odisha portion, they used to means absorb much of the energy deposited by the tropical cyclone, and due to this the cyclone cause less damage in the coastal area. And the fifth one is use of dry ice. Now we know that dry ice is used to cool a particular used for cooling purpose. So we know that tropical cyclones require a temperature of 27 degrees centigrade or more than that. So what happens that sometimes dry ice is spread in the oceans far away from the coastal regions, say 5 to 10 kilometers far away, so that the ocean temperature in those regions, it gets much below 27 degrees centigrade. And when tropical cyclone used to reach that particular area before striking the coastal surface, it used to means the source for energy for those tropical cyclones, that used to get reduced, and the intensity of tropical cyclone, that used to get reduced, and due to that the damage caused by the tropical cyclones in the coastal region also gets reduced. So this was our last heading under this tropical cyclones. I hope you people have noted it down. With this we come to end of this topic. In our next video we will study about western disturbances. Okay, I hope you people have noted it down step by step in a structured manner. Okay, this will help you to revise during the examination. Thank you.